Hello friends, myself MB Gaddi, lecturer in EC department from Nadasushi Polytechnic. Today I am going to discuss regarding after completion of diploma for higher education BE, that is DCET PPTs and multiple choice questions with answers. It is especially helpful for 6th sem EC students. The DCET exams are already you are going to face after completion of your 6th semester diploma examination. Now my subject is ARM controller. Now today I am going to highlighting the overview of ARM processor, that is first one ARM controller embedded system hardware. From small sensors found on a production line to the real-time control systems used on a NASA space probe are controlled by the embedded systems. The embedded system hardware is divided into four main hardware components. They are ARM processors, controllers, peripherals, bus. An ARM processor comprises a core and peripherals. Controllers coordinate important functional blocks of the systems. Interrupt and memory controllers are two commonly used controllers. Peripherals. The peripherals provide all the input-output capability external to the chip and are responsible for the uniqueness of the embedded device. Bus is used to communicate between different parts of the device, that is to exchange the data between the devices. Next one, AMBA bus protocol, advanced microcontroller bus architecture. Widely used as on the chip bus architecture for the ARM processor. Initially there are three AMBA buses. First one ARM system bus, second one ARM peripheral bus, ARM high performance bus. ARM has introduced two variations on the AHB bus, multi-layer AHB, AHB Lite. AHB allows a single bus master to be active on the bus at any time. The multi-layer AHB bus allows multiple active bus masters. AHB Lite is a subset of the AHB bus and is limited to a single bus master. Next point, ARM core data flow model. ARM core data flow model, it consists of the functional blocks connected by the data buses. Data enters the processor core through the data bus. The data may be an instruction to be executed or a data item. The architecture used may be von Neumann or Harvard. The details of different functional units are as follows. First one, instruction decoder, sign extend, register file, barrel shifter, ALU and MAC, multiply and accumulate unit. Instruction decoder, this unit translates the instructions into the binary form before they are executed. Sign extend, this unit converts signed 8-bit and 16-bit numbers to 32-bit values. Register file, register file called as storage bank is made up of 32-bit registers. Registers are named as R0 to R15. Barrel shifter, this unit performs barrel shifting operations on the operand and places in the ALU. ALU, arithmetic and logic unit. MAC, multiply and accumulate unit. Address register, the ARM processor used load and store architecture. Load and store instructions use the ALU to generate an address to be held in the address register and broadcast on the address bus. Incrementer, for load and store instructions, the incrementer updates the address register before the core reads or writes the next register values. After passing through the functional block units, the result in RD is written back to the register file using the result bus. Processor modes. The access rights of the processor mode are done in the CPSR register. A processor mode is either privileged or non-privileged. A privileged mode allows full read-write access to the CPSR. A non-privileged mode only allows read access to the control field in the CPSR but still allows read-write access to the condition flag. There are 7 processor mode, 6 are privileged and 1 is non-privileged. 6 privileged modes are: first one abort mode, second one fast interrupt request mode, third one interrupt request mode, fourth one supervisor mode, fifth one system mode, and sixth one undefined mode. Non-privileged mode is user mode. Pipeline mechanism. Pipeline is the mechanism used to execute instructions in a RISC processor. Pipeline increases the speed of execution process. In a three-stage pipeline, the stages fetch, decode, and execute. Fetch loads an instruction from memory. Decode identifies the instruction to be executed. Execute processes the instruction and writes the result back to a register. The procedure of filling three stage is called filling the pipeline. Pipeline allows the core to execute an instruction every cycle. As pipeline length increases, the amount of work done in each stage is reduced. This allows user to attain a higher operating frequency. Higher operating frequency increases the performance of the processor. Performance of the processor. The system latency also increases because it takes more cycles to fill the pipeline before the core and execute an instruction. The increased pipeline length causes data depending between certain stages. The characteristics of the pipeline are: the execution of a branch instruction causes ARM core to flush its pipeline. Exception and interrupt handling in ARM. An exception is any condition that needs to halt the normal sequential of the instructions. An exception might occur when an undefined instruction is encountered, instruction fetch or memory access fails, external interrupt has been raised, when a ARM core is reset, when a software interrupt instruction is executed, etc. Thus, exception handling is defined as the method of processing such exceptions. Most exceptions have an associated software exception handler. The exception causes the core to enter a specific mode. Even by changing the CPSR, any of the ARM processor modes can be entered manually. User and system mode are not entered by a corresponding exception. To enter these modes, CPSR has to be modified. The core automatically undergoes the following process in steps when an execution causes the mode change. Saves the CPSR to the SBSR of the exception mode, sets the CPSR to the exception mode, sets PC to the address of the exception handler, saves the PC to the LR of the exception mode. Exception according to priority and its associated. The table gives reset SVC protected mode for operating system, data abort, virtual memory and or memory protection handling. FIQ fast interrupt request handling, interrupt request, IRQ, interrupt request handling, prefetch abort virtual memory and or memory protection handling, software interrupt SVC protected mode for operating system, undefined instruction, undefined software emulation or hardware to process. Factor table. A factor table is a table address that the ARM core branches to when an exception is raised. Interrupts. In ARM there are two types of interrupts, namely the first type of interrupt causes exception raised by an external peripheral. They are IRQ and FIQ. The second type is a specific instruction that causes an exception. It is a SWI instruction. Both types suspend the normal flow of a program. Assigning interrupts. In an embedded operating system design, the FIQ exception is used for a specific application that requires a fast response time. IRQ exception is more general operating system activities. Software interrupts are normally reserved to call privileged operating system routines. Interrupt latency. Interrupt latency is the interval of time from an external interrupt request signal being raised to the first fetch of an instruction of a specific interrupt service routine ISR. Software handlers have two main methods to minimize interrupt latency. They are nested interrupt handler, second one prioritization. LPC 2148 CPU. Salient features of LPC 2148 microcontroller. It is a 32-bit ARM7 TDMI tiny LQFP 64 package microcontroller in a 8 KB to 40 KB on-chip static RAM and 30 KB to 500 KB on-chip flash memory. 128-bit wide interface accelerator enables high-speed 60 MHz operation. USB 2.0 full-speed compliant device controller with 2 KB of endpoint RAM. The LPC 2148 provides 8 KB on-chip RAM accessible to the USB by DMA. One of two 10-bit ADCs provide total 6 to 14 analog inputs with conversion time as low as 2.44 microseconds per channel. Single 10-bit DAC provides a variable analog output, two 32-bit timers, external event counters, PWM, 6 outputs, and watchdog. Low power real time clock RTC with independent power and 32 kHz clock input. Multiple serial interfaces including two UARTs, two fast I2C bus 400 kilobits per second, SPI and SSP with buffering and variable data length capabilities, factored interrupt controller with configurable priorities and vector addresses, up to 45 to 5 volt tolerant fast general purpose input pins in a tiny LQFP64 package, up to 21 external interrupt pins available, 60 Hz maximum CPU clock available from programmable on-chip PLL with settling time of 100 microseconds. On-chip integrated oscillator operates with an external crystal from 1 MHz to 25 MHz. Power saving modes include idle and power down. Individual enable or disable of peripheral functions as well as peripheral clock signaling for additional power optimization. Processor wake up from power down to mode via external interrupt or BOD. Single power supply chip with the POR and BOD circuits. CPU operating voltage range 3.0 volt to 3.6 volt with 5 volt tolerant IO pads. Pin connect block. Pin connect block allows selected pins of the microcontroller to have more than one function. Configuration registers control the multiplexer to allow connection between the pin and on-chip peripherals. Peripherals should be connected to the appropriate pins prior to being activated to any related interrupt. The pin control module contains three registers: pin cell 0, pin cell 1, pin cell 2. General purpose input output GPIO. Device pins that are connected to a specific peripheral function are controlled by GPIO registers. Separate registers allow setting or clearing any number of outputs simultaneously. The value of the output registers may be read back as well as the current state of the port pins. LPC 2148 introduced accelerated GPIO functions. GPIO registers relocated ARM local bus for the fastest possible IO timing. Masking registers allow treating sets port bits as a group, leaving other bits unchanged. Applications of GPIO: general purpose IO, driving LEDs or other indicators, controlling of chip devices, sensing digital inputs. Phase locked loop. There are two PLL modules in the LPC 2148. PLL not is used to generate CCLK clock system. PLL1 has to supply the clock for the USB at the fixed rate of 48 MHz. Both PLL are identical with the exception of the PLL interrupt capabilities reserved only for PLL not. PLL not and PLL1 accepts an input clock frequency in the range of 10 MHz to 25 MHz only. The input frequency is multiplied up the range of 10 MHz to 60 MHz for the CCLK and 48 MHz for the USB clock using current controlled oscillator. The multiplier can be integer value from 1 to 32. The CCO operates in the range of 156 MHz to 320 MHz. There is an additional divider in the loop to keep to CCO with its frequency range while the PLL is providing the desired output frequency. The output divider may be set to divide 2, 4, 8, 16 to produce the output clock. PLL activation is controlled via PLLCON register. PLL multiplier and divider values are controlled by the PLL CFG register. These two registers are protected in order to prevent accidental alternation of PLL parameters or deactivation of the PLL. The different registers of PLL, PLLCON, PLL control register, PLLCFG, PLL configuration registers, PLL STAT, PLL status register, PLL feed register. Timers. The timer or counter is designed to count cycles of the peripheral clock PLCK or an externally supplied clock and optionally generate interrupts or perform other actions at specified timer values based on 4 match registers. It also includes 4 capture inputs to trap the timer value when an input signal transitions, optionally generating an interrupt. The LPC2148 can count external events 1 on the capture inputs if the minimum external pulse is equal or longer than a period of the PCLK. Now we are going to what discuss regarding some DCT multiple choice questions. Here please note that totally 30 questions I have solved from question papers and from books. The star mark indicates the correct answer. First one question: what is the ARM processor used by ARM 7? Four options are there. First one 8-bit CISC, 8-bit RISC, 32-bit CISC, 32-bit RISC. Among them, the true answer is 32-bit RISC. D. Second question: what is the instruction set used by ARM 7? Choices are 16-bit instruction set, 32-bit instruction set, 64-bit instruction set, 8-bit instruction set. The correct answer is 16-bit instruction set. How many registers are there in ARM 7? Choices are 35 registers, 37 registers, 37 registers, 35 registers. Correct answer is C. 37 registers, 31 general purpose registers plus 6 SPR. Then fourth question is what are TDMI stands for in ARM 7 TDMI? Options are timer, debug, multiplex, ICE. Thumb debug multiplier IC. Timer debug modulation IS. Thumb debug multiplier IC. Correct answer is B. Thumb debug multiplier in circuit emulator. ARM stands for. Options are Advanced Risk Machine, Advanced Risk Methodology, Advanced Reduced Machine, Advanced Reduced Methodology. Correct answer is A. Advanced Risk Machine. What are the profiles of our ARM architecture? Options are first one AR, AM, A, R, M, R, M. Correct profile is A, R, M. ARM 7 processor comprises dash stage pipeline mechanism. Options are 4, 3, 2, 1. Correct answer is 3 stage pipeline B. LPC 2148 provides dash dash KB on chip RAM. Options are 8, 9, 10, 11. Correct option is 8. LPC 2148 consists of two dash bit timers. Options are 32, 16, 64, 8. Correct answer is 32 bit timers. Next question. LPC 2148 has dash UARTs. Options are 1, 2, 8, 6. It has 2 UARTs. Correct option is 2. LPC 2148 has dash dash pins. First A is 64, B 70, C 80, D 10. Correct is 64 pins. Next question. LPC 2148 has two power savings modes. A. Idle and power down. B. POR and BOD. C. ALU and CPU. D. None. Correct answer is idle and power down. Next question. Area, entry are dash dash of ARM. Options are A. Instruction, assembler directives, jump instruction, none. Correct answer is assembler directives. AAPCS stands for. Options are ARM Application Procedure Call Standard, Application ARM Procedure Call Standard, ARM Alphabet Procedure Call Standard, none of the above. Correct answer is ARM Application Procedure Call Standard. Three-stage pipeline of ARM 7 consists of following sequences. First one, fetch, decode, execute, execute, decode, fetch, 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 decode, none. Correct answer is fetch, decode, execute. Next question. All thumb instructions are dash bit long. Options are 8 bit, 32 bit, 64 bit, 16 bit. Correct answer is 16 bit long. ARM 7 processor provides dash dash code density. Options are medium, large, high, small. Correct answer is high code density. Next question. In ARM, there are two types of interrupts, namely, options are IRQ and FIQ, IRZ, IZR, IRP, IPR, and none of the above. Two types of interrupts, namely IRQ and FIQ, is the correct answer. There are dash dash number of PLL modules in LPC 2148. Options are 8, 2, 64, 16. Correct answer is 2. Number of PLL modules in LPC 2148. One more question. Up to dash dash external interrupt pins available for LPC 2148. Options are 21, 32, 23, 64. Up to 21 external interrupt pins available. Next question. An instruction that is used to move data from an ARM register to a status register into bracket CPSR or SPSR is called dash dash. Options are MRC, MRS, MSR, MCS. Correct answer is MSR. Next question. Instruction used to test equality of two 32-bit values in ARM 7 is called. Options are TEQ, TST, UR, none of the above. Correct answer is TEQ. One more question. LPC 2148 has dash dash byte of flash memory 128K, 256K, 512K, 1024K. Correct answer is 512K. AMBA stands for, options are Advanced Microcontroller Bus Architecture, Advanced Microprocessor Bus Architecture, Advanced Bus Architecture, none of the above. Correct answer is Advanced Microcontroller Bus Architecture. ARM consists of dash dash number privileged modes. Options are 1, 4, 3, and 6. Correct answer is ARM consists of 6 number of privileged modes. Thank you. These type of questions are available in what uh, appearing in DCT. We have to practice. Totally 180 questions will be there, including mathematics, science, and whatever you have studied up to first sem to 6th sem. Totally it is 3 hours exam. Total 180 marks it will be cover. Best of luck for your final exam.